introductory lesson about rational expressions and how to simplify them. First of all, defining what a rational expression is. Recall that rational numbers are quotients or divisions of integers. For example, 2/3, -5/2, 3/1, which is written normally as 3, are all quotients of integers and therefore rational numbers. Well, in a similar way, a rational expression is a quotient of polynomials. And polynomials are things like lines, quadratic functions, cubic functions, and so on, things with a base of x and an exponent that's a whole number. So some examples of rational expressions are here. The linear function 2x minus 1 over the linear function x plus 3, for example. I can have a linear function divided by this degree 2 quadratic function. They may be in a factored form or not. These are rational expressions. Now, one of the things that we need to know right away about rational functions is when they're undefined. So results that are undefined happen by division of 0 is one way. Now, another way is a radical with a negative value inside of it. Undefined is a shortcut for undefined in the real number set. So these don't produce real number results. So with rational expressions, they're undefined when the denominator is 0. So to find them, you'll set the denominator of a rational expression to 0. Here are a few examples. Function 2x minus 1 over x plus 3. It's undefined if the denominator is 0, or if x is -3. Now, this is a value that we're not allowed to have. Sometimes you'll see it as x cannot equal -3, or undefined if x equals -3. They say the same thing. Sometimes, by the way, these can be referred to as non-permissible results. Okay. The second function, hopefully you'll recall, can be factored. This quadratic can be written as x plus 2, x plus 3. And I'm interested to know when that equals 0. And you'll see that that results in two different values for x. -2 or -3 would produce an undefined rational expression. Over here, it's x times 5 minus x, and it's already in a factored form, leading to, maybe you should pause and try this and then see how you do. The first result is 0. The second result is 5, so 0 and 5. Undefined values. Okay, how to simplify a rational expression? Well, first of all, remember with rational numbers, if I had the rational number 4 over 6, I could write it as 2 times 2 over 2 times 3. So I have factored it. Now, the line means divide, and the dots mean multiply. Multiplication and division are inverse operations. So if you take a value and multiply by 2, then divide by 2, you get the original value. Multiplying and dividing undo each other. We can divide out these 2's. That's what the line means. We have divided 2 out. The result is the remaining 2 and 3, so 2/3. So 4 over 6 is equivalent and simplified as 2 over 3. Now we're going to do the same idea with rational expressions. So here are a couple of expressions. To simplify each, we're going to factor and then remove common factors. So the first expression, x plus 2 numerator, is a binomial factor. There's nothing I can do with it. And you may recall that I already saw this denominator and factored it above. It's x plus 2, x plus 3. So this x plus 2 on the top is a binomial factor. It's identical to this binomial factor here. We know it's a factor because of the brackets and the fact that they're multiplied onto another function, or another factor. So I can divide out the x plus 2 from the numerator and denominator. I'm left with an x plus 3. And note that the x plus 3 is a denominator. So don't write this as x plus 3 answer because x plus 3 is what you see. Notice it's on the denominator. It's 1 over x plus 3. it's good when you're working with rational expressions to work vertically. So you notice how I've written equal signs down the left and lined things up to help my eye see what's going on. Okay, you pause and try the second one and do your best effort at factoring it out and looking at the results and doing a reduction of common factors like I've done, and then rejoin me. All right, welcome back. Hopefully you got the answer 3 bracket x plus 2 over x plus 1, which is the factored form, or the expanded form, and both of these answers are good. Expanded isn't any simpler than a factored form. Also notice that there was a common factor of 3 and a difference of squares pattern. So there's a number of factoring patterns that may emerge that you'll have to recall from the past. So that's basic simplification. Now, there are a couple common types of errors that happen, and I would encourage you to pay close attention to these and make sure that you don't do them. Here is one common type of error. Presented with the function x plus 1 over x plus 2, people see the x and cancel it and say that this equals 1/2. This is wrong. The reason this is wrong is that the x is not a factor of the numerator or the denominator. It's being added. And this removal, this cancellation, is a division operation. It's dividing out a common factor. And so if it is not a factor that's in common, you can't do this. Here's another type of simplification that students will sometimes do. X squared plus x plus 4 over x plus 4. And students will see the x plus 4 in common and cancel all of that and say it equals x squared. This is wrong. And it is the same reasoning as above. X is not a common factor of the numerator. It's only a factor of the first 2 terms. There are 3 terms on the numerator. Likewise, 4 is not a common factor. It's a term on its own. And you can't cancel things that you observe that are in common someplace that aren't actually factors. Another similar kind of issue that can sometimes arise, something like 3 minus x and 3 plus x, and people would say, oh, that equals -1. This is also wrong. Just because they look very similar doesn't allow you to just remove everything. Ultimately, people are doing the same operation as above. They're just seeing common terms and wanting things to be simpler. That's basically it. There are other kinds of errors that can occur, but most commonly the types of things that people are doing is striking things out and canceling things just because they see something that looks like something else. You've got to discipline yourself to have common factors. Again, look back here and look at how I simplified these. I rewrote the rational expressions in terms of factors, and then I only look for common factors. Again, factoring, common factors. Good luck working on these questions.